Hello students, in the previous video we discussed about the discrete time Fourier transform, that is the Fourier representation of a non-periodic signal. So discrete time Fourier transform deals only with discrete time signals, and we listed the properties of discrete time Fourier transform, and we solved some properties of discrete time Fourier transform as well. Okay, now in this video we'll solve the remaining properties of discrete time Fourier transform, and we'll take some examples on this. Okay, so let's start with the next property, that is convolution. Okay, so convolution property. So the definition says if x of n equal the omega, then and y of n gives y of e power j omega, comma, then z of n is equal to x of n convolved with y of n. So this gives z of e power j omega is equal to x of e power j omega into y of e power j omega. Okay. So let's take the proof of this. So x of e power j omega is equal to summation n equals minus infinity to plus infinity x of n e power minus j omega n here. So call this as 1. Z of e power j omega is equal to n equals minus infinity to plus infinity z of n e power minus j omega n here. Now let's substitute the value of z here, x of n convolved with y of n e power minus j omega n. Now from the definition of convolution sum, we can write this term as summation. So I have used n here instead of I will use some other variable kl varying from minus infinity to plus infinity, x of l y of n minus l to e power minus j omega n here. So now for convenience I will change the order of summation. So changing the order of summation. So if you change the order, so I'll take L first here. L is equal to minus infinity to plus infinity x of L summation n equals minus infinity to plus infinity y of n minus L e power minus j omega n. So this is applicable for both of them. So that's why. So let's keep it as it is. So let's replace this n minus L with some other alphabet. So put n minus L is equal to m. So that implies n is equal to L plus m or m plus L. So that gives us summation L equals minus infinity to plus infinity x of L. Here the summation, so that I will change from m here. M equals minus infinity to plus infinity y of m e power minus j omega L plus m. Now if you split that, so this term e power minus j omega L and e power minus j omega m. So this term I will take outside the summation. So what you will get here, I have x of L e power minus j omega L into summation m equals minus infinity to plus infinity y of m e power minus j omega m here. Now compare these two with the definitions. So that is equation 1 or yes, equation 1. We can write this as e power j omega, and similarly we can write this as y of e power j omega. Okay. So here we started with z of e power j omega. So that is mean the convolution in time domain is the multiplication in frequency domain. So this is the proof of convolution property. So moving on to the next property, modulation. Okay. So what does it say? If x of n gives x of e power j omega and y of n gives y of e power j omega, then z of n. So it is just the reverse of convolution. So the multiplication in time domain will end up with convolution in frequency domain. So that is what. So here this 1 by 2 pi is for one particular period. So that's why this is also represented as the periodic convolution. So z of e power j omega is equal to 1 by 2 pi x of e power j omega convolved with y of e power j omega. So this symbol, it indicates a periodic convolution. Okay. So that is for one particular period we can consider. So let's take the proof of this. So x of e power j omega is equal to, so every time we define this just for the reference, that is the definition of Fourier transform or the analysis equation. Now if you substitute the value of z of n here, that is x of n into y of n e power minus j omega n here. So now this, if you recall from the definition of Fourier transform, that is the synthesis equation. So what does the synthesis equation says? X of n is equal to 1 by 2 pi integral of minus pi to plus pi x of e power j omega into e power j omega n d omega. Okay. Now I am going to use this synthesis equation in the above expression here, this one. I will replace x of n with this term. Now we have omega here, so we can't use the same thing because I am substituting the synthesis equation into this one. So that's why instead of this omega, we can use some other alphabet. So instead, I can use alpha, beta. So let's use beta here. This become beta, and this d omega. This also will become d beta. Okay. So that is the only change I am making this. So using synthesis equation, okay, you can call this as equation 2 in equation 2. So what happens to this? Z of e power j omega is equal to summation n equals minus infinity to plus infinity y of n 1 by 2 pi, I am substituting x of n now, minus pi to plus pi x of e power j beta e power j beta n d beta e power minus j omega n. Okay, so we have substituted x of n here. Now this for convenience, so interchanging the order of summation and integration. So this integration and this summation, if you interchange this, so first I will write this term integration minus pi to plus pi x of e power j beta. So summation n equals minus infinity to plus infinity y of n e power j beta n into e power minus j omega n d beta. Now if you observe this from frequency differentiation property, so I will go with the next step and I will write this one, 1 by 2 pi minus pi to plus pi x of e power j beta. So we can combine this, n equals minus infinity to plus infinity y of n common power base e power minus j omega minus beta n d beta. Now if you see this, as we did in the frequency differentiation property, so based on this term you can see this, we have this is nothing, it is similar to y of e power j omega, but in place of omega we had omega minus beta. So I will write this from differentiation property, or as we did in the differentiation property, I will write this as 1 by 2 pi integral minus pi to plus pi x of e power j beta. So this as y of e power j omega minus beta into d beta. Okay, x of e power j beta y of e power j omega minus beta to d beta. Now if you recall the definition of convolution integral, it says integral of, so 1 by, so integral convolution integral, it says x of n y of, sorry I have to write it in x of tau y of t minus tau d tau. So this is for one particular duration, 0 to t, or this will be one particular period, time period t. Now if you observe this, this is in, these terms are is in frequency domain. The limit is for one particular duration here, minus pi to plus pi, and in you have this tau represents the time index here. Here it is e power j beta, where beta is representing the time index, and here if you observe this, we have omega minus beta. So this term, that is the time shifted version, and in place of tau we have beta. That means with respect to tau we have to integrate here, and here we are integrating with respect to beta. So comparing these two, so this is from convolution integral. Comparing these two, we can say this is nothing but the convolution of x of t and y of t. Now this, we are getting the same thing in frequency domain. So in frequency domain we are representing this, here beta represents the time index. So if you compare these two, So this is nothing but the convolution of two sequence x of e power j omega and y of e power j omega. So based on this, we can write, I am just leaving this for reference. So based on this, we can write this term as 1 by 2 pi into x of e power j omega convolved with y of e power j omega, and this we started with e power j omega z of e power j omega. So hence this is the proof. Okay, so I am leaving this part for the reference, that is from convolution integral. Okay, so this is what we get from convolution integral. So based on this, so here this one is in time domain, but here this one is in frequency domain. So hence this is the proof for the modulation property. So if you move on, the next property is Parseval's theorem. So it says if x of n gives x of e power j omega, then summation n is equal to minus infinity to plus infinity x of n square mod of x of n square 1 by 2 pi. Here this 2 pi is for one particular duration, x of e power j omega whole square d omega. So here if you observe this, the LHS of the expression, so it is nothing but the energy expression for the signal, so that we discussed in the very beginning of the signals and system. It is also called as the energy spectrum or energy density spectrum of the signal x of n. That means you see this x of e power j omega, x of e power j omega whole square. So this is the energy density spectrum of what? Of x of n square. Okay, just x of n. Okay. So now we'll start with the energy expression for this one. So the energy of the signal is calculated by E of E is equal to x of n square. Now you can observe this, we have to consider mod means, so we have to consider both the real and imaginary part as well. So we represent that signals in two different form, n equals minus infinity to plus infinity x of n and its complex conjugate form x star of n. So both we have to consider here. Okay. So now we have x of n. So the synthesis equation, it says 1 by 2 pi. So call this as 1 by 2 pi. So here also the limit is 2 pi, that is one particular duration, x of e power j omega, e power j omega n d omega. So this is from the synthesis equation. So if x of n is this, then x star of n is equal to 1 by 2 pi, the duration will be the same. This one will be x star of e power j omega. So this term, this is, since it is complex conjugate, so this imaginary will be the reverse of it, that is the negative of that d omega. Okay. So using above equation in equation 1. So, now use this x star of n, we substitute this here in equation 1 and let us see what happens. So, we get 1 by I think I forgot the summation here, summation n is equal to minus infinity to plus infinity x of n. Now, I am replacing this x star of n with this term x star of e power j omega e power minus j omega n d omega. Okay. So, again changing order of summation and integration. So, now we are changing the order of summation and integration for our convenience. So, 1 by 2 pi integral of, so this is for one particular duration, integral of 2 pi x star e power j omega summation n equals minus infinity to plus infinity x of n e power minus j omega n d omega. Now, this term is nothing but x of e power j omega, that is the analysis equation x star of e power j pi omega, and this we can write as x of e power j omega d omega. Okay. So, now observe these two. So, we have the same thing in expressed in frequency domain, the real and imaginary, the complex conjugate. Now, if you take the magnitude of this, so 1 by 2 pi integral of x of e power j omega, combining this square d omega. Okay. Now, this side we started with summation n is equal to minus infinity to plus infinity x of n whole square. Okay. So, I think this is the proof for the Parseval's theorem. So, moving to the last one, symmetry. So, there is no proof here, I just mentioned what symmetry property is. I will just write it down. If x of n gives x of e power j omega, then for real value, so then if x of n is real value, then x of x star of e power j omega is equal to x of e power minus j omega. So, if x of n is real and if it is an even signal, then the transformed version of this will be having the imaginary part as 0, that is x of e power j omega will be 0. If x of n is real and if it is odd, then the real part of x of e power j omega be 0. So, this is what the symmetry property says here. Okay. So, this completes the properties of discrete time Fourier transform, and I will take one example in this video only, and in the next one we will take some examples on this based on the properties and all. Okay. So, let us start with this. So, let us take the first one. So, in this given, find the DTFT of the signal x of n is equal to alpha n into u of n. So, I will write it down here clearly because there is a condition you have to understand. X of n is equal to alpha n into u of n, where mod alpha is less than 1. Okay. Draw its magnitude spectrum. Okay. So, now first we have to find the Fourier transform version of this, and then we have to draw the magnitude spectrum of the given signal x of n, which is denoted by alpha n into u of n, where alpha mod alpha is less than 1. So, this condition is very important while plotting the magnitude spectrum, okay, and while getting the final answer as well. So, from the definition we have x of e power j omega is equal to summation n is equal to minus infinity to plus infinity x of n e power minus j omega n. Now, substitute the value of this x of n here, n equals minus infinity to plus infinity. What is x of n? Alpha n into u of n e power minus j omega n. So, u of n is 1 for values of n greater than or equal to 0, and u of n is 0 for n less than 0. So, therefore, x of e power j omega. So, our limit here minus infinity to plus infinity limits only for values of n which are greater than or equal to 0. So, therefore, n varying from 0 to infinity alpha n. So, in this particular duration, what is the value of u of n? 1 alpha n into 1 e power minus j omega n here. Now, let us combine this. N equals 0 to infinity alpha e power minus j omega whole to the power of n. Okay. So, this is for my convenience, I am doing this. Why? So, from the geometric series we have summation n equals 0 to infinity a to the power of n is equal to 1 divided by 1 minus a. So, where a is not equal to 1 here. Now, based on this, we can write x of e power j omega as, in place of a we have alpha e to the power of minus j omega. So, we can write it as 1 divided by 1 minus alpha e to the power of minus j omega. Here the condition, so that is what the final answer for this. Now, we have to plot the magnitude spectrum for this. Given the mod alpha is less than 1. So, that means alpha can take positive values or negative values. So, it can take positive value or negative value, we do not know. So, now the magnitude spectra we have to represent for the signal in frequency domain. So, we have to consider the alpha for two different cases, one for positive values, another one for negative values. So, if you take the values for alpha as positive, so alpha will be from greater than less than 1 but greater than 0. So, this is for positive values. If alpha takes negative value, then it means it will be between minus 1 and 0. Okay. So, this is the meaning of this. Let me check yes, alpha, yes, right. If it takes negative values, Okay. So we have to consider these two while plotting the magnitude spectrum for this. Okay. Now for alpha, so first case, for positive values of alpha, that is alpha between 0 and 1. So what happens here, x of e power j omega is 1 divided by 1 minus alpha e power minus j omega. Okay. Observe here, so this is the time omega here. So we have to plot x of e power j omega. Okay. Now this will be in terms of pi, 2 pi and so on. So observe this, it can take only positive values. So that means alpha value will always be positive, even though it will always be less than 1, that is what it is saying. So it will be, the amplitude will be positive only. Now observe this, if I put omega is equal to 0, so then x of e power j omega is equal to 1 divided by 1 minus alpha e power 0. So that is 1 by 1 minus alpha. Okay. And if I put omega is equal to pi, x of e power j omega is equal to 1 divided by 1 minus alpha e to the power of minus j pi. Now this term, if you convert into the trigonometric form, so you will get cos pi minus j sin pi, so that is a value, cos pi value is minus 1 and j sin pi value is 0. So you will get minus 1 here, so that is 1 divided by 1 minus alpha into minus 1, so you will get 1 by 1 plus alpha. So if you substitute omega is equal to minus pi, so x of e power j omega is equal to 1 divided by 1 minus alpha e to the power of j pi. Again you will end up with 1 by 1 plus alpha. If you simplify this, that means here the amplitude is mainly dependent on what alpha takes. Okay. So here at this point, these 2 points, the value is 1 divided by 1 plus alpha, 1 divided by 1 plus alpha. In this point, it is 1 divided by 1 minus alpha. Okay. Now the amplitude is mainly based on this alpha, which is varying from 0 and 1. So the values of this are greater than 0, less than 1. So what if, and you can go for 2 pi, if you substitute 2 pi, you will end up with 1 divided by 1 minus alpha, and for minus 2 pi also you will get 1 by 1 minus alpha only. So the same thing will repeat for a time duration of 2 pi. Okay, so that's why I'm not going to calculate that part here. Now if you have 1 divided by 1 minus alpha, say alpha takes a positive value, so that is if alpha is equal to, just for instance take, it is taking a value 1 by 2, so what you get, 1 divided by 1 minus 1 by 2, so that is 1 by 1 by 2, so you get 2 as an amplitude. This is just for illustration. For 1 by 1 plus alpha, if you take alpha is equal to 1 by 2, then it will be 1 divided by 1 plus 1 by 2. So that is 1 by 3 by 2 or 2 by 3. 2 by 3 means its value is 0.66. So the amplitude of 1 minus 1 by 1 minus alpha is 2 and 1 by 1 plus alpha is 0.66. Now based on that 2 you will get somewhere here, 0.66 somewhere here. Okay, both at plus pi and minus pi. So based on this, we can plot. So it will decrease here, and at 2 pi again it is going like this, and again in the next instance it will come back, and the same thing happens here. And now how this thing will you're going to get means, here it is 1 divided by 1 minus alpha, this one is 1 divided by 1 plus alpha. So that is what the amplitude, again here it is 1 divided by 1 minus alpha, and these things will keep on going. Okay. So the magnitude values won't be changed here. So if alpha takes positive value, so this is what it will look like based on the values at 0, pi and minus pi. So you get the amplitude 1 by 1 minus alpha, 1 by 1 plus alpha, and 1 by 1 plus alpha. And here I have explained, if it takes positive value of alpha, if you take any positive value between 0 and 1, so this is what you are going to get. Now for the same sentence, same, if you take for negative value of alpha, so that means the value of alpha will be between 0 and minus 1. How the plot will be? X of e power j omega. Now I mentioned this point pi and 2 pi here. So here I am not going to calculate this amplitude values because it will be the same, but one thing is alpha should take negative value. So you will get at this point, you will get 1 divided by 1 minus alpha. Here it is 1 divided by 1 plus alpha. So this is the previous instance. Now if alpha value is negative here, if it is negative, so then this becomes 1 divided by 1 plus alpha, and this becomes 1 divided by 1 minus alpha. Okay. So this is the major change here. So let's see that what happens if you substitute the value for this. Okay. If alpha takes negative value, then x of 0 is equal to 1 by 1 minus alpha becomes 1 divided by 1 plus alpha, and at x of pi it will be 1 divided by 1 plus alpha, that goes to 1 by 1 minus alpha. Same happens for x of minus pi if it takes the negative value. Okay. So 1 plus alpha becomes 1 divided by 1 minus alpha. Okay. Now you have to apply over the positive values for alpha only. Now if you apply 0, any value like 1 by 2, you can do two different ways. One is you can change the values of alpha here and apply the positive value for that, or if you want to avoid, I'm not getting this, I am getting more confused means, don't bother to do all these things here. So put the values for this negative values. Alpha is equal to minus 1 by 2. So that will give you 1 divided by 1 plus 1 by 2. So that is 1 by 3 by 2, 2 by 3. You will get 0.66. So for this one, 1 divided by 1 minus 1 by 2, that is 1 by 1 by 2 is 2 here. And here also 1 divided by 1 minus 1 by 2. Y means alpha negative value. I am applying negative value here. 1 divided by 1 by 2. So again you will get 2 here. So that means at 0 the amplitude is 0.66, and here it is 2, and here it is 2, and here again it is 0.66, 0.66. Now if you combine this, the spectrum will look like this here. and it will keep on going. Okay. So if alpha takes negative value, the value should be between 0 and -1. We have applied -1/2. Okay. So if you want to express this, here it will become 1 divided by 1 plus alpha. Here it will be 1 divided by 1 minus alpha. So that is the representation, or as it is you can keep it here, no change. I want to make no change here, 1 plus alpha here and 1 by 1 minus alpha here as it is, no change in that, but alpha takes the negative value. So that's why you will get the spectrum like this. Hope you have understood this one. So if you have any queries, do reply or comment in this video. So this is how the magnitude spectrum is drawn for two different cases. Thank you for your time. So do reply or comment on this video.